Hello, today we're going to be looking at the Pythagorean theorem. Main thing I want to point out about the Pythagorean theorem is it's only going to apply to right triangles. So it's worth noting that that's going to be an important thing to remember. So in any right triangle, the sum of the squares of the two legs is equal to the length of the squares of the hypotenuse. Now, some pieces of information we need there. So if you look at this diagram right here, you're going to see we have the legs are going to be the two shortest sides of the right triangle. They come together to make the right angle. The hypotenuse is always across from the right angle, and it is the longest of the three sides. So using the description of the Pythagorean theorem, we can see the formula is a squared plus b squared equals c squared, which literally means if you square the legs, meaning multiply them by themselves, both a and b, then find the sum of the two squares, it'll be equal to the hypotenuse squared. So this unique relationship, again, only exists with right triangles. So an example of this that you can see off to the side here, if we have this triangle here, it has two legs that measure 4 and 3. If I were to square the two legs sides, so 3 squared and 4 squared, I would get 9 and 16, and that would equal the sum of the hypotenuse, the square of the hypotenuse, which is 5 squared or 25. And we can, of course, verify that 9 plus 16 does equal 25. So knowing this theorem, it allows us to solve for missing pieces of right triangles if we have the other two. So you just have to make sure that you put them in the correct spot. So if we look at example 1, we notice that in A, we are solving for the hypotenuse. So I identify right away that it's the two legs that I'm given, and I'm going to be looking for hypotenuse. So when I set this up, I start with just the basic formula. So a squared plus b squared equals c squared. And then I go ahead and insert my leg values in for a and b. So when I put 5 in for A and 12 in for B, and then I leave C the variable, and then 5 squared is 25, 12 squared is 144. Then I add those two together. 25 plus 144 would be 169. So 169 is equal to C squared. Now, to get rid of the squared, the only way to undo that is to take the square root. So now I will take the square root of both sides, and I'll find that C is equal to 13 centimeters. So that's my missing side there. On the other one here, we have a hypotenuse given. We can see that because it has the side that's not attached to the right angle. And then we have one of the legs missing, and that's y. So when I set this one up, it's still a squared plus b squared equals c squared, but this time it's one of my legs that's missing. So I'm going to put 8 squared first, which it doesn't really matter which one you put in for which leg, A or B. That is irrelevant. I'm going to put y in for b, and then c would equal 12. So now I square 8 and I get 64. I square 12 and get 144. And now I subtract both sides, minus the 64. And I would find that y squared equals 80. So again, in order to find that missing side, I'm going to have to take the square root of both sides. And when I take the square root of 80 to the nearest tenth, I would get 8.9 units. Okay, in example 2, we have a bit of a challenge here. So this one, we're asked to find the area and the perimeter. So I noticed right away I can't find area because I don't have the height. And I can't find perimeter because I don't have this outside measure here. So I actually have two different steps I'm going to have to do. So I notice that this triangle, even though the whole triangle is not right, it is split with a segment down the center from the top vertex, which turns it into two right triangles. So I can use the Pythagorean first to find the height of the triangle. So if you notice, if I'm just looking at this triangle here, BCD, I have the hypotenuse and I have one of the legs. So using the Pythagorean theorem, I'm going to fill that information in. So I'm going to put in 3 squared plus b squared, which will be our height, equals 5 squared. So I would end up with 9 plus b squared equals 25. Now I subtract 9 from both sides. And I find that b is equal to 16. So now I can, b squared is equal to 16, sorry. And now I can take the square root and find that b equals 4. So that gives me the height of the triangle. So that's good. But now I also need to find that missing measure for AB in order to be able to find perimeter. So the next thing I'm going to do is I'm going to use the 2 legs of this triangle, ABD, in order to solve for the hypotenuse. So again, using a squared plus b squared equals c squared, I should be able to do this. So I'm going to put in 7 for one of the legs, 4 for the other, and I would end up getting 49 plus 16 equals c squared. Now I can add up 49 and 16, and I get 65. And to undo the squaring, I would take the square root of both sides. And I would end up finding that c is equal to about 8.1 to the nearest 10th. So now I can go back and put that in for my triangle. So now I'm still not finished because I need to calculate perimeter and area. So I would start with perimeter. It doesn't really matter, but we'll start with perimeter. So perimeter would equal all 3 sides added up. But in this case, that's going to be segment AB, which is 8.1. It's going to be AD and DC because they both comprise the base. And then it's also going to be the 5. So when I add those all up, I end up getting 23.1 units. For area, I know my formula for a triangle is 1/2 the base times the height. So I would do 1/2 of 10, because that's the base of the entire triangle, times the height of the entire triangle, which is 4. So I'm going to get half of 40, which is 20 square units. Okay, next. In example 3, again we're asked to find perimeter and area, but we can see there's going to be 2 steps that we need to do. So the first one is going to be to find the height of the whole triangle, because I can see that I have segment AB, which is a hypotenuse, and AC, which is a leg. So my initial formula, and I'm going to probably run out of space here, is going to be a squared plus b squared equals c squared, but this time I'm missing a leg. So I'm going to put 9 in for A. I'm going to leave B the variable, and then 12 in for C. So then I'll end up with 81 plus B squared equals 144. Now I subtract 81 from both sides, and I find that B squared is going to be equal to 63. So now I have to take the square root, and when I do, to the nearest 10th place, I get 7.9. So that tells me that this height of the triangle is 7.9 centimeters. Okay, now that I have the height, I also am going to need the bottom leg here, CD. So now I can see in my second triangle that I have a leg and a hypotenuse. So you really just have to treat each problem separately based on the information that you're given. So in this one, I'm going to have the 7.9 squared plus b squared, which will equal 11 squared. So 7.9 squared, as we know from the previous step, is about 63. And 11 squared is 121. So now I will subtract 63 from both sides and find b squared is about 58. Then I have to take the square root of both. So the square root of 58 is going to be about 7.6 to the nearest tenth of a centimeter. So that tells me that my dimension down here is 7.6. So now I have to find perimeter and area. So if I'm finding perimeter, it's going to be all of those outside measures. So perimeter would equal 11 plus 12 plus 9 plus 7.6, and that will be a total of 39.6 centimeters. For area, I remember for a triangle it's 1/2 base times height. So here my base is a total of 16.6 and my height is 7.9. So when I multiply those together, I'm going to get 65.6 centimeters squared. So now we're going to move on and try a trapezoid. So let's take a look at this trapezoid. We first will count the base. So when we count over, we can see the base is 1, 2, 3, 4, 5, 6, 7, 8, 9 units. The height, straight up and down, is going to be 1, 2, 3, 4 units. So we could actually find the area already. To find area, we would just simply use the formula from yesterday, which was base 1 plus base 2 times half of the height. So for base 1, we would put in 9. We have to add the, second base, so 1, 2, 3, 4, 5 up top. And then times half of the height, which would be half of 4. So then we end up with 14 times 2, and we get 28 square units. Next, to find the perimeter, we realize we're missing the slant heights. Now we can see that this is an isosceles trapezoid, meaning both of the sides are the same for the slanted measures, but I have to figure out what that is. So if I notice that this is actually a right triangle right here, I have a base of 2 and a height of 4. So those are both the legs of my right triangle, so I can find the hypotenuse by using the Pythagorean theorem. So what I'm going to do over here, we're just focused on that right triangle, and we'll use a squared plus b squared equals c squared, and we'll fill in both of our legs. So we have 4 squared plus 2 squared, and we're looking for the c value. So that'll end up being 16 plus 4 equal to c squared, which is 20. Then to solve, to undo the squaring, again I have to take the square root. So I would end up finding that c is equal to about 4.5 units. So now, to find perimeter, I would go back to the whole figure. I know the bottom measure was 9. I'm going to squeeze this in here. The bottom base was 9. I know that both slant heights are 4.5, so I would count those in twice. And then the top base was 5. So when I add all of those measures together, I would get a perimeter that is 23 units. All right, and then we take a look at the last question, which is a scenario. Let's read through that now. So it says, you are building a slide for your little sister in the backyard. The sliding board measures 10 feet, and the ladder that you build measures 8 feet. How far away should the bottom of the slide and the base of the ladder be on the ground? So it might be helpful to draw a little picture here. If we draw a picture of this, basically what we have is, we have the slide itself, we have the ladder, which would be straight up and down, and we're trying to figure out how far away the base of the ladder is from the tip of the sliding board. So if we know that the ladder itself is 8 feet, we know that the sliding board is 10 feet. And what we have here is a right triangle where we have the hypotenuse and one of the legs. So we need to solve for the other leg. So using the Pythagorean theorem, I would put a squared plus b squared equals c squared. And I would take my 8 and make it a. It doesn't really matter which one is a and which one is b. And then plus x squared, and then that's going to be equal to my hypotenuse squared, which was 10. So 8 squared is 64. 64 plus x squared equals 100. Now I have to solve, so I'm going to subtract by 64 on both sides because the goal is getting x by itself. I end up with x squared equals 36. My final step then is to take the square root on both sides, which will tell me that x equals 6 feet. So the base of my ladder will be 6 feet away from the bottom of the slide.